guys, today I'm going to speak about boost or buck converters. So first of all, I'll tell you what a boost converter is. Boost converter is used to step up. It's a step up converter and it is used to step up DC voltage. It's the main thing. These boost and buck converters are used for DC voltage and not for AC voltage. So the boost means step up and buck means step down. So boost is step up and buck is step down. So first let us see how we step up or step down AC voltage. So so if you write AC voltage is stepped up or stepped down using a transformer, which symbol is like this. This is the symbol of the transformer, and a transformer is used to step up or step down an AC voltage. But whereas in DC case we can't use this transformer. It would just we can't use DC voltage with a transformer, so we use buck or boost converters. So I'll draw a simple diagram of a boost or buck converter. These converters mainly work with the principle of inductance. So diagram is like this. A battery is here. This is positive and this is negative. This part negative and this is a positive. This is a normal battery, everyday battery. So let's start from the positive terminal. The voltage comes from there and goes into an inductor. After the inductor, then it goes through a diode like this and then into a capacitor over here. This is a DC electrolytic capacitor, and the negative terminal is connected like this, and there is a switch here. In between. So I have made that circuit in a very simple manner. It's roughly made. I didn't make it in a PCB. So this is the inductor here. This is the diode. I have taken this inductor is 100. You can use any value inductor, but I am using 100 microhenry. And diode I am using IN4007. It's the most common diode used everywhere. This is a push button switch. And capacitor, any electrolytic capacitor, but as I didn't have a smaller value capacitor, I was using 400 volt, and I'll show you 400 volt 22 UF capacitor, 400 volt 22 UF capacitor. This is a battery. So first of all I will explain how the circuit works. So when the switch is open, the current will flow through the inductor, through the diode, and it would come here and charge this capacitor, and the voltage of this capacitor initially would be the voltage of the battery itself. So when we press the switch, when we press the switch, this would get closed. This path would get closed, and the current would flow like this through the inductor, then through the switch, and then back to the terminal. So what happens here is that a small charge of the battery is stored inside the inductor. This is the inductor. charged inside the inductor and it would stay for some micro or milliseconds, and when we release the switch, again this terminal is cut, and here the voltage would come like this and go through the diode. So there was a small charge in this inductor, and this would add up to the charge of the battery. So for example, let this battery be 1.5 volt, and when we close the switch, it stored an energy of some 1 volt, no need 1.2 volt, and when this passed through the diode, this diode would have a loss of something 0.2 to 0.7 volt. So 0.2 to 0.7 volt, as every diode has a voltage drop. So in this case we can take 0.2 volt is a drop. So after closing and opening a switch, one cycle is completed, this capacitor would be charged with a charge of, when we add this, it will come 2.5, as 2.5 volt will be charged here, as 2.7 volt should have come here, but due to the diode a small drop is there and the output voltage will be 2.5. and when we continue this cycle on off like that, this voltage would increase. It could increase up to, there's no limit here, but most commonly commercially available boost converters will step up the voltage up to 60 volt. This is the maximum voltage for a commercially available one. So the circuit which I have made can step up the voltage up to 25 volt. I didn't check it thoroughly, so I'm not clear of that. Okay, this is the main working principle. First, charge is stored here when the switch is closed. When the switch is closed, this is charged, and when the switch is open, that charge adds to this battery's charge, and that extra charge is used to charge the other capacitor. So I will show you what my multimeter shows. Okay, let's move the board. So my circuit is ready. You can see I have put the multimeter in 20 volt, and my battery is here. I'm going to connect the cable here. So at first it's showing the battery voltage with a small drop here due to the diode. So let me start pressing the switch. Oh sorry, just the cable went off. Look, when I put the cable itself, it's short. Okay, I'll just short that and reduce the voltage. Now it's 0 volt, and when I touch here, it's showing the battery voltage. Now the switch, look how the voltage is increasing. This is the main principle how a boost or buck converter works. Let me see till how much voltage I can increase this. Maximum till 8 volt. It's going till 8 volt. So let's make this much more a simpler circuit by removing the switch, and instead of the switch we can introduce a transistor, and I have made this circuit. I have used a transistor over here. I hope you can see it. It's not clearly visible. So I will show you the circuit diagram of this. First I will show you the working. Then I'll show you the diagram. So I removed this cable, so I'm just moving away this circuit. And now instead of the switch, this will work as a switch. My transistor, my circuit, it's a very loose connection. I put this here. So my circuit is here. This is the output positive voltage, so I connect it here. I'll show you the diagram now. It had some charge. I'll just discharge it. Did you see that spark? That was just created by this small battery. I'll show you. Just take the end off. So positive side I have connected. It's a little bit long wire. Get this. My negative cable will go here. So this battery is of 1.5 volt, and now the circuit is creating 15, 20, it's more than 20 volts, so I'll put it to 200, and it's showing 21.22. It's keeping on increasing. And it's now slowing down. 25 volt. This is what I told over there. So I'll show you the diagram, and let me show you how much voltage I create. So I stored that voltage in this capacitor, and I'm going to short this. Did you see that? It's powerful. So this is the main working principle of these boost and buck converters, and I'll show you the diagram now. So I'll draw the diagram and show up the circuit. First, let's draw the inductor. I'll draw it like this. This is my inductor. I just drew a larger one because I put a bigger core, and the main part of this is I am taking a center tap out of this coil, and that's this cable. This is a center tap of this core, and this part would act as, this is the feedback coil, and this part would oscillate. This is the main part which would oscillate, and this is the feedback coil. So let's see how we connect. So I'll just draw the transistor over here. This is a transistor. The name of this transistor is D. I can't write here, it's too small. It's D882. It's D882 transistor. I don't think so. Just my camera window. My lighting is not proper, so you can't see the transistor. So if we keep the transistor like this, then the three connections will come like this. My first connection is here, second to here, and this is my VCC. Whenever we see VCC in a circuit, this would mean that this is the input positive side. So I'll write positive side of the battery will go there. Then after coming like this, the next part is this part of the transistor which would come out and go to the capacitor. It would go to the negative side of the capacitor. This is the negative side of the capacitor, and the positive side is here. Positive side is connected to the middle part, with a diode, that is IN4007 diode. Now it would get connected to here, so positive, and these two are the output, and here we would get 25 volt. Input side negative is this part, this is the negative, and other part is a positive, negative or ground, you can see. So I'll just remove this. So this is the main diagram. This is the inductor. I'm just repeating it. So this is my diagram, and using the transistor D882. It's not very efficient. This circuit is not very efficient because of this transistor. This transistor will get heated, although we are using 1.5 volt. I'll write 1.5 volt in, out. So this is my diagram, and this is the front part of the transistor. I'll write the base emitter. So this is the emitter, this is the collector, and this is the base. In the last video I somehow told I just mispronounced some of the spots in the last video, and my one comment came, and thank you for commenting under my video, as I understood that you had shown some interest in my videos. Okay, so this is my circuit, and I don't have a commercial one which is working, because I have destroyed almost all of my boost converters. I have a full box of this with these converters, step up and step down both, but most of them I fried because I took more voltage from them than they are rated. I only have this one, which is a step down one. Most of these are based on an IC which is named, I'll just write the name of that. And most of these ICs are based on XLSEMI, which is the company name of this, and it's XL6009E1. This is a company name, XL. So this is mainly used for step up. This is not a transistor, this is an 5-pin IC. You can see here, this is a 5-pin IC. It's used for step up, which is the common one, and the other one is XL4015E, which is used for step down. And these also work in the same principle, but these generate oscillations. I mean, it's not oscillation. Okay, they create a frequency of more than 2 to 3 kilohertz, and that when we rectify that output, we would get a higher voltage. That's what they are using here. This lithium battery charging circuit board, it's a specially designed buck converter. This is a step down converter. This is the input part. I use this to charge my lithium ion batteries. It's a very powerful one. It could charge up to it could be loaded up to 5 amperes. So thank you for watching my video. Please like my video if you like my contents, and also don't forget to subscribe and share my video. wanted to tell an additional fact that this circuit can work with the small battery only, and if you use a much bigger load, this transistor would burn away. And one more thing, this circuit is has another one more name, and it's famously known as Joule thief.